Hi everyone. Okay, so I'm going to take you through questions 1 to 5 from the homework, the forces homework. So question 1, most people are getting this right. It's not too bad, this one, but it's still easy to make little errors. Let's first draw a little diagram, what's going on. Something's being projected up. Oh, that's a bit wonky. Something's being projected up from a point which is already above the ground. I'll do my U in a slightly different color to some of the other stuff. So U is, and it was given in the question as, well, actually it would say, you were asked to show that U is 21. So I'll just put U as question mark for the moment, actually. But we do know that it was 17.5 meters above the ground. So we can put that as 17.5 meters. And actually it's going to go up and then back down again and hit the ground. Now, what else do we know in this question? We also know that when it reaches the ground with a speed of 28 meters per second. Now, straight away, I can see something which is going to massively confuse people. That speed with which it hits the ground, and I'll just put it on my diagram so it's nice and clear. Let's actually draw it as an arrow. The reason why we should draw it as an arrow is because it's a vector. Arrows are vectors. Vectors are arrows. It has a direction. And so whatever U is, it should be the opposite sign to what V is. And V is 28. Yeah? So let's actually write that as equals V. Equals V. Oh, sorry, I've just realized that. Yeah, equals V. Okay, and then I think I've got everything I need on my diagram, but I can see how this kind of question would stress people out a little bit straight away. We're going to have U equals question mark, A equals, now here's your choice. Personally, I prefer taking up as positive and just remembering that gravity is always negative, but then you must have V as negative 28 as well. And what else have we got here? You've also got S is minus 17.5. I would suspect that most people actually did those all as positive, I would guess. But it's a little bit tricky, that. So anyway, we've got V squared is U squared plus 2AS. And so we've got 28 squared. I don't know what 28 squared is. Let's just quickly ask Mr. Calculator. 28 squared, 784 equals U squared. And this is going to be plus 2 times 9.8 times 17.5, and that gives me 343. Subtract and square root, and you get U equals, hopefully the answer they told us it was going to be. Yes, indeed, you get U is 21 meters per second. So that's part A. Part B, at time t seconds, P is 19 meters above A, and A is the point of projection. A on my diagram is there. So if you're 19 meters above A, then S is 19. U we can now use as 21. A is minus 9.8, and we're looking for T. So T is, Lord knows what, but T equals question mark. S equals UT plus a half AT squared. Put it all onto one side. I probably prefer to put it onto the left myself, but it doesn't matter which side. Ask your calculator, and you should get two answers there. You get T equals 1.3, I believe, and T equals 2 almost 3. So 1.3 or 2.99 seconds. There we go, and that's part B done. C is the most difficult bit, actually, because C actually describes it going into some mud, I believe. Yeah, so I'm going to draw another diagram out for this. You'll see anybody who teaches you these kind of mechanics questions, maths, will always insist on a diagram, and for good reason. Okay, the ground is soft, and after P reaches the ground, yeah, so this is P. It sinks vertically downwards before coming to rest. Now P is 4 kilograms. So we'll put 4g, that's the weight going down. And the ground is assumed to exert a constant resistive force of magnitude 5,000 newtons. And we've got to find the vertical distance that P sinks into the ground before coming to rest. Well, this is a little F equals ma problem. You've got stronger forces minus weaker forces equals mass times acceleration. It might even be better to look at it in a slightly different way here. If we just say that down is positive, you've always got to decide in these kind of questions, like a direction to all of your vectors in the question. I'm going to take down as positive because it's traditional for me anyway. I take the direction of movement as positive normally. I just like taking the direction of movement as positive. But I can see it's decelerating, it's slowing down. So I should get a negative acceleration here. But this is an F equals ma problem. And so if we've taken down as positive, we'll have 4g minus 5,000 equals 4a. And from that, I can work out the acceleration. And 4 times 9.8 minus 5,000 divided by 4 comes to minus 1240.2. Now you might look at that and say that is a crazy answer. Minus 1,000 meters per second squared. Well, no, that is a very realistic answer actually, because when you drop like a ball in the mud, it basically slows down from going really quite fast to completely zero velocity almost instantly, and that is a massive deceleration, and so we would expect the deceleration to be very, very large there. Now, we've got to find the vertical distance it sinks. This is now a SUVAT problem. We know that when it hit the ground, our initial speed was 28 meters per second. Yeah? And that's from part A, where it said it hits the ground with a speed of 28 meters per second. We know our deceleration is minus 1240.2, and it should be the opposite sign to the speed, because the speed is going down whereas the acceleration is going up. So it should definitely have the opposite sign. We've also got v is 0 because we know it becomes stationary, and we're looking for s. Well, then it's a v squared is u squared plus 2as problem. And if you plug those numbers in, you're going to get 0 equals 784 minus 2480.4 times s. And eventually that should give you, well, let's have a look, 2480.4 divided by 784. I'm getting an answer of, oh, hang on, I've done the division the wrong way around. Everybody does it sometimes. Watch out to get the division the right way around. 0.316 meters. And it's done. And that sounds like quite, not unrealistic anyway. 30 centimeters sinking into the ground. I suppose it's quite far, but seems okay to me. Okay, I hope that was useful. I'm going to pop up an answer for question 2 in a minute, and I know that many of you found that probably the toughest on the paper, so look out for that one. Okay, bye-bye.